Greetings everyone. I'm going to explain to you how to take a system of linear equations and put it into a matrix equation. From there we're going to put it into a coefficient matrix and then an augmented matrix. We'll get into echelon form and reduced echelon form later on in this video. We're going to start off with two simple systems of linear equations. We have two unknowns, s and t. Basically, we're going to rewrite the coefficient in one matrix and call it A, and multiply it by a unit vector that we're going to call X, and it's going to be equal to this column vector here, which is B. Basically, if we wanted to put this matrix, this matrix equation back into this system of linear equations, we will simply take 11 times S plus 4 times T is equal to 7. Negative 1 times S minus 4 times T is equal to negative 5. And just like that, we're back to this form there. Okay? Like I said, this is A times the unit vector X times the unit vector D, which gives us our matrix equation. Now, if we take a bigger system of linear equations, one with 3 equations and 4 unknowns, simply we would take these coefficients straight off the out of the equation and rewrite it into its own matrix. Can you see that? Okay, so I have 1, 2. I don't have a coefficient there, so it's 0. We have negative 1, 1, minus 2, so forth and so on. If I wanted to make this into an augmented matrix, I would simply remove the right side of this brace, add an augmented line, and add the equations, the solutions to the linear systems here. I would add these solutions to the right side of the matrix, and thus we have our augmented matrix. An augmented matrix has the solutions to the system of linear equations here. Okay, so I'm going to take that same example, which I've rewritten for you in augmented form, and I'm going to use a series of row operations to get zeros in this lower triangle right here. These 3 numbers, I want them to have 0. I'm going to start by switching, interchanging row 2 with row 3. Simply, I'm going to switch these rows. I've switched those rows, so now row 3 is row 2 and row 2 is row 2 is now row 3 is row 2 and row 2 is row 3, and this is what we get here through a series of operations. And you can see there, if you can take a screenshot or a quick picture right there, I have all my row operations on top of my matrix so you can follow me. But this here is row echelon form. In row echelon form, all non-zero rows are above any rows of all zeros, and the leading coefficient of a non-zero row is always strictly to the right of the other leading coefficients of the row above it. Okay, so negative 2 is strictly to the right of 1, negative 1 is strictly to the right of negative 2, and these are the leading coefficient, and we have our 3 zeros, so this is in row echelon form. If I would like to put it into the reduced row echelon form, I will have to continue with my row operations until I get this beauty right here. Look at all these zeros here and here. Here are our leading coefficients, our pivot positions. In order to be in reduced echelon form, it must first be in echelon form. And then for every leading coefficient is 1 and is the only non-zero entry in the column. So 1 is the only non-zero entry in that column. 1 is the only non-zero entry in that column. And same for here. 1 is the only non-zero entry in the column. So guys, if you need, take a quick picture so you can follow my row echelons, my row operations, so you can get what I get. Try it out yourself and let me know how it goes, okay? Thanks for watching.